All right, so this video is to help you review for your upcoming quiz over 3.5 to 3.7. And so we're just going to go through one of each kind of problem. I'm not going to do all the problems, so you at least have a guide to go by, and then you can go back and finish the other problems on your own and make sure you check your answers with the key posted. So let's start with number one. We're dividing using long division. Now you have all your success criteria in detail in your notes, but I'm just going to shorten that for you. So basically, dividing with long division, you're going to divide, multiply, subtract, and then bring down the next term. Bring down, okay? So we start by setting it up. The divisor is the one on the bottom there, so x minus 2. And then the dividend would be the numerator, the one on the top there. And remember, you always need to check for missing terms. So make sure you have all your terms. So I'll check my exponents. 3, 2, 1, constant. So we're good. We don't need to fill in any zeros. So we start by dividing our leading term. So I'm going to do x to the third divided by x. X to the third divided by x would be x squared. So that's my first term of my quotient. Now I take that x squared and I distribute it to my divisor. So x squared times x is x to the third. X squared times negative 2 is negative 2x squared. So that was step 2, multiply. Now I'm ready to subtract. So start with a negative 4x squared minus negative 2x squared. Minus a negative turns to a positive. So this is negative 2x squared. Those cancel out. And now I'm ready to bring down my next term. Plus 2x. Then start all over again. So divide. Negative 2x squared divided by x would be negative 2x. Now multiply. Negative 2x times x is negative 2x squared. Negative 2x times negative 2 would be positive 4x. And now subtract. 2x minus 4x would be negative 2x. Those cancel out. Bring down your next term. And start over. Negative 2x divided by x is negative 2. Now multiply. Negative 2 times x is negative 2x. Negative 2 times negative 2 is positive 4. Subtract. 5 minus 4 is 1. So I have a remainder of 1 here. And I'm going to write my remainder as a fraction. So it's positive 1 over divisor x minus 2. And then this is the answer right here. All right, so now you're ready to do number 2 and 3 on your own for practice. Let's skip down to number 4. It says, is the binomial a factor? So is b minus 7 a factor of this polynomial here? So in order for it to be a factor, you must get a zero remainder. Must get a zero remainder. If you don't get a zero remainder, then that means no, b minus 7 is not a factor. So let's try that out. So remember, you're going to do opposite this, because if you were to solve for b, you would get positive 7. So positive 7 is your divisor. And then use your coefficients here from the dividend. So make sure they're in order. 4, 3, 2, 1, constant. We're good to go. We do not need to fill in any zeros. So 1, negative 8, negative 1, 62, and negative 34. Start always by bringing down your first term. So I'm going to bring down that 1. And now the process is multiply and then add. So I'm multiplying the divisor by this number down here. So 7 times 1 is 7, and now I'm going to add down. Negative 8 plus 7 is negative 1. Then start over again. 7 times negative 1 is negative 7. Add. Negative 1 plus negative 7 is negative 8. Then start over. 7 times negative 8 is negative 56. 62 plus negative 56 is 6. 7 times 6 is 42. And then I can already see that's not a zero remainder. So I can just say no, not a factor. Why? Because you get not a zero remainder. This is not 0. All right. So you would do the same thing here. So set it up. Divisor would be negative 2. Use those terms. If you get a zero remainder, it's a factor. If you don't get a zero remainder, then it is not a factor. All right, going down to number 6, it says divide using synthetic division. So that's the process we just went over. And we're also going to write our answer in factored form. So we're going to start by finding our divisor. Our divisor is positive 7 there. And then our terms are 1, negative 13, 40, 18. All terms are present. We don't need any zeros. Start by bringing down the first term. And then you multiply, add, multiply, add, and then multiply, add. Remember, the last term is always your remainder. And then to find the answer here, you start 1 lower than your degree that you started with. So the degree we started was x to the third. So this is going to be x squared and then x. And then this is the remainder here. So if I want to write this in factored form, I would start with the divisor. So it's divisor times quotient. Okay, so my divisor is the x minus 7. Then my quotient is here, x squared minus 6x minus 2. And then, of course, I have that remainder of 4, so just plus 4 at the end there. Okay, so that's what you're doing for number 7. Let's look at number 8. It says, use the remainder theorem to find the value of f of negative 2 for the polynomial. So there's 2 ways you can do this. You could plug in negative 2 in for x and simplify, or you could divide by negative 2, and whatever the remainder is would be the answer. So I'm just going to go ahead, there's not a whole lot of space, so I'm just going to go ahead and plug in that negative 2 there in for all of the x's, and then simplify. So I would get negative 8 plus 4 plus 10 minus 6. Then I would simplify that and I would get 0. So now the remainder theorem says that my f function evaluated at negative 2 is 0. But I also could have found that by synthetic division. So I would set it up like this. And then I would do my process. And then my remainder would be my answer. So 2 ways to do it. Either plug in the value or synthetic division is the other method, and then the answer is the remainder there. So either way to do that. All right, number 9 you'll do on your own. Let's move on to the next page. Okay, we're gonna actually skip the next page. None of that was on your quiz this year. We've done it in the previous years, but we're skipping over it this year. So actually, we're going to go all the way to 14. Skip all the way to 14, so you can cross out 13 as well. It says, what are the real and or complex roots of the polynomial function? So first, you need to plug this into Desmos. So use Desmos to find a real root. Oops, use Desmos, I'll just say for real root. And that would be any x-intercept. Okay, so I'd plug that in and I would see that I have an x-intercept at x equals -1. So I'm plugging this into Desmos. I have one x-intercept at -1. So that's my real root there. The x-intercept is the real root. And then I'm going to use that real root to find the other root. So I'm going to use -1 as my divisor and use synthetic division here. It's missing that constant, so I have to fill in a 0 there. Multiply, add, multiply, add, multiply, add. Okay, so we started with x to the 3rd, so this would be an x squared, x constant there. So now I have 3x squared minus x. So there's two ways to do this. You can either factor or you can use the quadratic formula. So always check to see if you could factor first. That's the easiest method. And this one you can. You can pull out an x, and it would factor down to this. And now I would set each of these equal to 0, each factor equal to 0, and solve from there. So I have my x equals -1, my x equals 0, and then I would solve here, x equals 1/3. Now remember the rule, this highest exponent tells you how many roots there are. So there are 3 roots. So I found them, 1, 2, 3. These are all real roots, which means that there are no complex roots, because we can have at most 3 roots, and here they are, and they're all real. Now sometimes you're not able to factor, and you have to use a quadratic formula, and that's usually when those imaginary roots occur. So look for that in the next one when you do 15. So you'll be trying that one on your own. Okay, let's look at 16. A company sells headphones. Their profit P in thousands of dollars is modeled by the equation of numbers of headphones, also measured in thousands. Okay, so both the profit and the headphones are measured in thousands, so keep that in mind. Describe the 0 for in context of this graph. So here's this graph down here. So the question is, what does this 4 mean? So we talked about profit and loss. Any positive interval would be profit, and any negative interval or any interval below the x-axis would be loss. But what does this 4 mean? Well, the 4 is a turning point from profit to loss. So that means at 4, or in this case, remember they're in thousands, so in 4,000 headphones, they're making no profit or no loss. So that 0, that x equals 4, is the break-even point for this company. And that would be the answer there. So just one more time. The key things you need to know about this is intervals above the x-axis are profit because they're positive. Intervals below the x-axis are negative, so that makes them loss. And any zeros here, that 4 would be the break even. That's the turning point there. The break even when no money is either made or lost. Okay, so let's move on to 17. Okay, solving these inequalities by graphing. Okay, so step 1, plug this into Desmos to graph it. So graph with technology. So I'm just going to put all this in just as I see it, parentheses and all, into my graphing technology, and I will find that I have zeros at 4. Oops, that's the wrong way. Sorry about that. 4 is over here. 1, 2, 3, 4. Positive 4 and negative 3. 1, 2, 3. And the graph looks something like this. It doesn't have to be perfect because we're only really interested in these zeros and the intervals that connect them. So after I graph, I'm looking for zeros. So those are my negative 3 and 4. So mark your zeros. And then we have to determine, is it going to be positive or a negative? So this is determined by the inequality sign. So this polynomial is less than 0. Anything less than 0 would be negative. Any number less than 0 is negative. So I'm looking for negative intervals. So my negative intervals, so I'm going to go ahead and highlight that. Highlight those intervals. Just grab my highlighter here. Okay. So negative intervals are below the x-axis. So I'm looking at this piece right here. This is one continuous piece, which means I only have one interval to give. So that's the last thing, give interval. And I always want to write this as an inequality. As an inequality. So these are all the x values from negative 3 to 4. So it looks like this, 3 less than x less than 4. And this is my answer here. All right, you go ahead and try 18 on your own. Make sure you're checking it against the key. All right, going down to 19. What are the zeros and multiplicities? First of all, we have a couple typos here. I want you to go ahead and add those x's at the end. So that should be 12x for A, and for B it should be 16x. So how do you do this? Well, first you need to factor. So factor completely. So you always look for that GCF first. What is the greatest common factor of x to the third, 7x squared, and 12x? Well, they all have an x, so that's their greatest common factor there. So I'm going to pull out an x to start. That leaves me with x to the squared, or x squared plus 7x plus 12. And now I'm going to see if I can factor what's left over inside here. So looking for the factors of 12 that add to 7. So that would be 3 times 4. 3 times 4 is 12, but 3 plus 4 is 7. So that's how I found that. And then you're going to set each factor equal to 0. So x equals 0, x plus 3 equals 0, and x plus 4 equals 0. And then solve for x. So x equals 0. Oops. Whoa. Sorry about that. x equals -3, and x equals -4. And those would be your zeros. Now, multiplicity just means how many times do each of these zeros occur, or how many of these do you have of each? So I just have 1 0, so that's a multiplicity of 1. I just have 1 -3, so that's also a multiplicity of 1. And then just 1 -4, so again, multiplicity of 1. All right, so that's what you're doing there for B. Let's look at the last page. So determining even, odd, or neither based on the graph. So you're not going to have to do it based on the equation for this quiz, only based on the graph. So can you tell these? Well, it's even if it is symmetric to the y-axis. It's odd if it's symmetric to the origin. And neither would be no symmetry either to the x-axis or to the origin. And then keep in mind, in order for it to be symmetric to the origin, it has to pass through the origin as well. So F has neither y-axis or origin symmetry, so this is neither. E is symmetric to this y-axis here, so that makes it even. And then C is symmetric to the origin, so that's odd. So there's an example of each type, and then you can go ahead and finish the rest there on your own. 21, how does the graph differ from its parent function? So you start with the parent function. You're given x to the fourth. X to the fourth, that's the parent function. So x to the fourth here. So the only thing changing here is this -9. And the -9 is outside parentheses. So that's going to be a vertical shift down. So this is going vertical shift down, and then 9 units. And that would be the answer there. Let's do one more together. Let's look at C. So you can do B on your own. Let's look at C. So my parent function is this x to the 6. So I want to determine what is this 5 doing, what is this negative doing, and what is this -2 doing to my graph. Well, the negative out in front makes it a reflection over the x-axis. This 5 out in front makes it a vertical stretch by 5. So remember, if it's a whole number greater than 1, which 5 is, that's a stretch. If it's a fraction less than 1, so say like 1/2 or 2/3, that would be a compression. But this is not a fraction, and 5 is greater than 1, so that's a stretch. And then -2 is inside the parentheses, so when it's inside, it's either going to go left or right, and since it's minus, it's going to go to the right. So that's a horizontal shift, right 2. So that would be your answer. All right, that's all I have for you there. I just want to change one thing. Let's look at D. This 1/2 should be outside parentheses there. Inside parentheses makes it something different, and we didn't learn that. You will learn that in pre-calculus, so go ahead and fix that for me. Put that 1/2 in the front, outside of the parentheses. Okay, So make sure you are finishing this up and checking your answers.